Have you ever looked at your drain and thought, where does all that water go? And more importantly, could I ever drink it again? It sounds like something out of a sci-fi movie, but today we go in to explore a fascinating question. Can you actually turn wastewater into clean, safe drinking water right in your own home? Let's dive in. First off, what exactly is wastewater? It's basically any water that's been used. We usually categorize it into two main types: grey water and black water. Grey water comes from your showers, sinks, and laundry. It's dirty, sure, with soap, dirt, and maybe some food scraps, but it's not as contaminated as black water. Black water is the stuff from your toilet. It contains human waste and is packed with harmful bacteria and pathogens. Dealing with black water is a serious business and requires intensive industrial-level treatment. So for our home experiment, we're going to focus entirely on grey water. It's the more realistic starting point. So how would we even begin to clean this grey water? The journey from dirty to drinkable involves several key steps. The first one is filtration. Think of it as a bouncer at a club, but for dirt particles. We need to get all the big stuff out first: hair, lint, food bits, and any other solids. You could start with a simple mesh screen, kind of like a kitchen sieve, to catch the larger debris. Then you'd want to move on to progressively finer filters. Imagine layers of gravel, sand, and then even finer sand or cloth. Each layer traps smaller and smaller particles. This multi-layer approach is a classic water filtration method that nature itself uses. As water seeps through the ground, different layers of soil and rock purify it. We're just recreating that process on a smaller scale. After we've filtered out the solids, the water might look clearer, but don't be fooled, it's still a microscopic party in there. This is where the next crucial step comes in: purification. This is all about killing the invisible enemies, the bacteria, viruses, and other microorganisms that can make you incredibly sick. One of the oldest and most effective methods is boiling. Bringing water to a rolling boil for at least 1 minute, or 3 minutes if you're at a high altitude, is a tried and true way to kill most pathogens. It's simple, reliable, and doesn't require any fancy equipment other than a heat source and a pot. So, after filtration, boiling our grey water would be a non-negotiable step to make it biologically safe. But wait, there's more. Even after filtering and boiling, the water might still have dissolved chemicals, soaps, detergents, and other funky stuff that gives it a weird taste or smell. This is where activated carbon comes to the rescue. Activated carbon is amazing stuff. It's been treated to have millions of tiny pores, which dramatically increases its surface area. 1 gram of activated carbon can have the surface area of a football field. These pores act like magnets, trapping and absorbing chemical impurities, pesticides, and compounds that cause bad tastes and odors. Running your boiled water through an activated carbon filter, which you can find in most commercial water pitchers or build yourself, would be the final polishing step. It's like giving your water a spa treatment, making it not just safe, but also pleasant to drink. So let's recap our homemade system. Step 1. A multi-stage filtration process using screens, gravel, and sand to remove all the solids. Step 2. Boiling the filtered water thoroughly to kill all the harmful microorganisms. Step 3. Running the boiled water through an activated carbon filter to remove chemical contaminants and improve the taste and smell. In theory, if you follow these steps meticulously, you could turn grey water from your shower or sink into water that is chemically and biologically safe to drink. The science is solid. Filtration, boiling, and carbon adsorption are all proven methods used in water treatment plants around the world. Now, for the big reality check. While it's theoretically possible, should you actually do this? Here's my professional and very strong advice. Please don't. Let me explain why. Building a DIY system that is 100% effective 100% of the time is incredibly difficult. A tiny mistake, a small gap in your filter, not boiling for long enough, or using exhausted carbon could lead to serious illness. Municipal water treatment facilities are massive, sophisticated operations with constant monitoring, rigorous testing, and multiple redundant safety systems. They have labs that test the water at every stage to ensure it meets strict safety standards. You just don't have that capability at home. You can't test your water for every possible pathogen or chemical. The risks of getting it wrong are simply too high. We're talking about things like E. coli, Giardia, or even chemical poisoning. So, what's the practical takeaway here? While you shouldn't turn your bathtub into a drinking fountain, understanding these principles is super useful. This knowledge is invaluable for emergency preparedness. If you're ever in a survival situation without access to clean water, knowing how to filter and purify water from a stream or river could save your life. The same principles apply. Filter out the gunk, boil it to kill the germs, and if you have the means, use a carbon filter. Many portable survival filters on the market use these very same technologies. Furthermore, recycling grey water for non-drinking purposes is a fantastic and highly encouraged practice. Instead of just letting it go down the drain, you can easily set up a system to divert grey water from your washing machine or shower to water your garden, your lawn, or your non-edible plants. It's a great way to conserve water, especially in dry areas. There are commercially available grey water diversion systems that make this process safe and easy. They typically include a basic filter to catch hair and lint, so you don't clog up your irrigation system. This is a practical, safe, and environmentally friendly application of our wastewater knowledge. It reduces your water bill and lessens the strain on our municipal water supplies. In conclusion, the science of turning wastewater into drinking water is real and fascinating. At home, you could theoretically build a system using filtration, boiling, and activated carbon to purify grey water. However, the risk of contamination and illness from a DIY setup is far too great to recommend it for drinking. The real value is in understanding the process for survival scenarios and, more practically, applying it to recycle greywater for things like irrigation. So, while you probably won't be sipping your shower water anytime soon, you can still put that water to good use and make a positive impact on the environment. It's all about using science smartly and safely. Thanks for joining me on this deep dive into water purification. If you found this interesting, hit that like button and subscribe for more videos where we explore the science behind our everyday world. Stay curious, stay safe, and I'll see you in the next one.